All right, now we want to continue building out our token. And in this video, we're going to handle delegated token transfers. So what does that mean? Well, in the last video, we basically implemented a transfer function and kept track of the token balances. In this video, we're going to allow other people to spend our tokens. All right. So if you go back to the ERC20 spec that we've been referencing, it's got this transfer from function, right? So this allows a value to be transferred to a certain address and also specify who the from address is, right? So in our example, transfer is always from the perspective of someone who's calling this function, right? msg.sender is always going to be the from value, and two values, we just pass that in. So what we want to do is create a function that accepts an arbitrary from value and an arbitrary to value. So why would we do that, and how do you do that? Well, why would we do it is because we want our tokens to be bought and sold on cryptocurrency exchanges, right? And whenever a trade happens, the cryptocurrency exchange itself is actually going to be doing the transferring, right? So it's not good enough for it to, just say, use the transfer function. We would have to send our tokens to a cryptocurrency exchange, and then they could potentially run off with them, right? We don't want that to happen. Essentially, what we want to do is approve a cryptocurrency exchange to spend our tokens for us, and we can revoke that approval at any time, okay? So when we do that, we need two functions. We need a way to approve tokens. Sorry, let me just put some space in here. So say approve tokens. And we also want to say, transfer from. So step one, we'll say we allow someone to spend our tokens. And step two, we'll say they're going to actually do the transfer instead of us. All right, we can see that in the ERC20 spec. Transfer from function, we need an approval function. And that's going to depend upon an allowance, which we'll see in a minute. All right. Now it's going to emit an approval event, just like we did with the transfer event. Approve must be approval. And then transfer from is also going to emit the transfer event. Okay. So we're going to build all that out step by step in this video. And when we're finished with that, we'll be done with our ERC20 token. It'd be awesome. We'll have a real-world cryptocurrency that we can, use. So let's write some tests in order to check the behavior. All right. So what we want to do is just do approvals first. That's going to be the easiest thing to start off with, and it'll be a prerequisite for, transferring the tokens. So add some space here so we can bump this up on the screen. And I'm going to say describe approving tokens. Describe approving tokens. And I'm passing this function. And just like we did with this other example, say let result. So let amount. That's just like we did in these previous examples. See, let result amount. And we're going to, describe success, describe failure, have a before hook. So we spent a lot of time on that in the last video, but now that you know how it works, I'm going to speed things up a little bit. So we'll say describe success and pass in this function. And then we'll also describe failure. Failure. We'll fill this in. All right, so for describing success, we'll say it allocates an allowance for delegated token spending. All right, this will be async. Pass in a function. So what we want to do is basically say, hey, cryptocurrency exchange, I'm going to allow you to spend tokens for me. And if you look at the ERC20 spec, that is tracked with this thing called an allowance, which we also need to implement, right? Allowance. So I'm going to approve some tokens to be added to your allowance, all right? And then whenever that's done, you can transfer from tokens, all right? So let's try to read the value of the allowance. We'll say const allowance equals await token.allowance. And let's just do this from the perspective of the deployer. So deployer, and then we'll say new account. So let's keep track of a new account that's going to be sort of the delegated exchange in this case. So let's just call it exchange. All right, say exchange. Remember, you can add more accounts to your test example like this, just by adding them to this array. Deployer exchange, we'll just say on an exchange. Okay, and now we want to get that value, and let's check it. So we'll say allowance toString should equal, and then we'll say an amount, which we'll add in a second, toString. All right, so now let's set the amount. We're just going to say before, for each, async function, and we'll say amount equals tokens, 100, and results equals await token dot approve. All right, which we're going to implement. So we haven't implemented this allowance or this approve yet. We're going to do it. We're just going to write the test first. And we'll say, you know, exchange. We're going to approve the exchange. And we'll say amount and from the deployer. And we're using deployer because we know the deployer has tokens, right? The deployer is going to approve the exchange for 100 tokens. And then we're going to check to see that that amount of tokens was actually added to the allowance, right? That's the first thing we want to test for. And we haven't written any of the code in Solidity to do this yet. So let's go ahead and do that now. So the first thing is you want to keep track of the allowance, right? So we're going to create a mapping for that. Just like we did balance of, we're going to create a new mapping that tracks, how many tokens the exchange is allowed to expend. So we'll say a mapping. And this is actually going to be a little bit different than our other mapping. The first key is going to be the address of the deployer, so the address. But the value of this mapping is actually going to be another mapping. So it's going to be a nested mapping. We'll do that like this. And say address, and this is going to be uint 256 of the actual value. Say public allowance. All right, so I'll explain this. This might be really confusing. This is where we keep track of how many tokens the exchange is allowed to expend. So this address is going to be the address of the person who approved the tokens, and then this is going to be, all of the places that they have approved tokens to spend. This could be multiple exchanges, right? Exchange 1, exchange 2, exchange 3. But in our case, we're just going to have one. But then the next key is going to be the address of the specific exchange and then the amount that it's allowed to spend. All right. And when we call this public, Solidity does give us a function to read this, but this function is going to take two arguments, right? The first argument is going to be the person who is approving the tokens, and the second one is going to be the place that they've approved them, and that's going to return the amount that's approved. So this is basically saying, for the deployer, what's the allowance that I've provisioned for this exchange? All right, give me that value. And then we turn that into a string, and we make sure that it's equal to this same amount that we approved the exchange for, right? Here we're just saying token, approve this exchange to spend this amount, right? And that's going to get added to the allowance. So that's a lot, but let's continue working on this. Now we need to create the function to actually do the approval, okay? So we'll do that like this. A function approve. And if you go back to our ERC20 spec, let's see the arguments that it requires. So approve, must be the spender and then the value, and it must return a Boolean that describes the success status. All right, so let's see here. What we want to do is do it like this. So I say approve, address, spender, say uint 256, value, say public, returns bool success, just like we did in the previous functions. And now inside of here, we want to create the behavior. So we'll say allowance msg.sender, and then we want to dig into this further, right? It takes a key that corresponds to a mapping, and then that mapping has another key value pair. And we say, let's see, spender. And that's going to equal the value. All right, so that's the core functionality. And there's some more things we're going to have to implement, but that's the basics. That's what we want to test for to make this pass, to satisfy this test. All right, so let's try to run the test and see if it worked. There might be some issues, but we'll find out soon enough. So truffle test. All right, it worked. Awesome. So we see a little warning here from Truffle that it returned success, but it didn't. So let's go ahead and do that. We'll just say return true. All right, the error or the warning said, it expected this value, but it didn't get it. So let's try it again. All right, so it worked. And all right, there we go. We got a passing test. We got this approve function that updates our new allowance mapping, right? And we exposed a function here that we can read out in our test. So there's going to be a few other things that we need to do. Per the ERC20 spec, it needs to implement an approval event. Right? Approve must implement an approval event. We can see the approval event down here. All right. So let's actually just copy this and paste it into our code. So I'm going to do it like this. You've already seen how events work, so I don't need to belabor this point. Just adding a new one. All right, so event approval, and then address from the owner, and then the spender, and then the value. So I'm going to actually remove these. Well, we can add, let's remove these for now. I'm going to keep them this way just so we're consistent with our code styles. All right, so we can emit it inside of our code like this. We'll just say emit, just like we did with transfer, emit approval, and we'll say MSG, sender, spender, and then a value. And we can test for the approval event just like we did the transfer event. I'm actually going to copy this, speed things up a little bit, and I'm going to put it inside of here. Describe success, and we'll say it emits an approval event. I'm actually going to capitalize transfer. All right, and then it must be approval. So owner should equal the deployer, I believe. All right, and so owner is correct. And then spender, and then value. So should be spender. This is going to be the exchange. And then value to string should equal amount to string. Value is correct. All right, let's run the test and see what happens. All right, it worked. So there is our successful implementation of token transfer events. Alrighty, so let's continue building out this approve function. Lastly, we want to check for failure, and basically we want to do the same address check. We want to say, require that the address is valid. All right, so we can check for that inside of our failure case like this. We say for failure, we try to approve an invalid address from the amount, and it should be rejected. So we're going to run our test like this. Oh, and we see we got a little issue here. I just copied and pasted this loosely without checking. So it's not 2 in this case, it's spender. All right, save this from the test again, see what happens. All right, it worked. So now we actually want to implement the function that allows the cryptocurrency exchange to spend the tokens or actually make the trade with the transfer from function, right? You go back to this ERC20 spec, it talks about that, this transfer from function, it transfers a value to an arbitrary to address. And we can see we also want to, throw an error if the from address is not authorized, like if they're not approved to do this, okay? So we can implement that function like this. All right, take out these comments. Let's say function transfer from, say address, from address to, and then uint 256 value. Say public returns bool success. All right, so there's the skeleton of our function. All right, so first let's just say returns true. All right, now we want to do the actual transfer logic inside of it, okay? So it's basically just going to do the same thing the transfer function does, but a little more. So let's actually refactor some of this transfer function into an internal function, okay? So we can share it and reuse it. So what I'm going to do is say function underscore transfer. That's just going to be a convention that says this is an internal function only. And inside of here, we're going to say from and address to. Sorry, I need to specify the type here. So it's address. Address from, address to, and then also the value, uint value. And this is going to be a different modifier, so it's or visibility. It's going to be internal. So we're not going to be able to call this transfer function like in our tests or anything. It's only going to be inside this smart contract. Okay, and inside of this, we're going to basically take out all of this, all right, and we're going to put it inside. We're going to put it inside here. So I'm going to copy this out, put it inside here. I'm going to take this out as well, put it inside here. And now we're going to call the transfer function inside here. The transfer, and then we'll pass in the required values. We'll say MSG, sender, to, and then value. All right, and now we need to refactor this a little bit. This is going to be from, and then to is correct, and then value is correct. All right, and we always want to emit the transfer event anytime a transfer happens. So transfer from, we're going to use this function inside of here, and it's going to emit the transfer event, and we're going to get this requirement for free as well. So let's just run the test at this point to make sure everything passes. Make sure that our refactor worked. That's another really nice thing about these truffle tests. Anytime you make a code change for your smart contract, you know, you're going to be safe to do that because you've got test coverage, full unit test coverage. All right, so now that's finished. And it worked properly. So now we can use this transfer function, sorry, this one, inside of this transfer from to, you know, do it. And we're going to, you know, basically write a new test. So I'll add some space here. And I'm going to use the, let's see, sending tokens as a starting point. So we'll just paste this in. I'm going to modify some things. We're going to basically comment out this stuff. We don't have to run yet. And we want to, we do emit a transfer event, so I'll just leave this. But I'll comment it out for now. We're going to check one thing at a time. And let's say it transfers token balances. We're going to change that. And yeah, okay, so we're just going to modify this stuff, and we'll run the tests, and we'll update the other stuff later. So first, let's say it transfers token balances inside success, but we want to actually do the transfer from function here. And we want to say the deployer. And we want to go to the receiver and the amount, and this is going to be from the exchange. All right. So tokens is going to be 100, and we want to try to, transfer them that way. So let's actually do another before each hook up here, and say before each. Let's set this up a little further. Oops, sorry. We're going to put the amount in up here. And we can do that because we said, let amount, and we can access that from anywhere inside this. And now we're actually going to approve the tokens. We need to do that first before we do any of our other success cases. So now we'll say, amount's going to be await token approve spender. Oh, this would be the exchange in this case. Exchange, and then amount. And then we're going to pass in, from, let's say deployer. All right, so quick recap. We have to do some setup before we can actually call transfer from. So first, we have to approve tokens. We're going to approve 100 tokens to the exchange, right? And we're going to do it from the deployer because that's just who has all the tokens right now. And this is the amount, right? And then inside this success case, we're going to actually do the transfer, from the deployer to the receiver. And the exchange is going to do it. And the only reason they can do it is because they've been approved to do it. All right? And so whenever that happens, we're basically going to say the balance of the deployer should be this, and then the balance of the receiver should be this. And that's because the exchange did that for us. So let's just run the test and see what happens. All right, so we get an error, and that's because the transfer didn't happen. That's because we didn't write the code to do it yet. So we got a failing test. Let's make it pass. We'll say transfer. And inside of here, we'll say from, to, and then value. All right, and that should give us all the transfer functionality for free when we do this in the tests. All right, and it passed. We've actually updated the balances properly. Okay. So there are a few other things we want to do. We want to make sure that it triggers a transfer event. So I'll uncomment out this code. Let's do it again to get the spacing right. All right, so let's see. In this case, should be a transfer event. From should be the deployer. To should be the receiver. And the amount should be the amount. All right, so let's run the test. All right, and it failed. So I'm actually glad it failed because it's showing us an error that we didn't change in our code yet. That's why we have tests. That's why it's so important to test smart contracts. Okay, so do you know what it is? Can you guess? Do you see it? Do you see it? You can pause the video and see if you see it. All right, if you don't see it, what happened was we didn't change this. We didn't change msg.sender inside this transfer event. Okay, so we need to change this to from. All right, let's do that again. All right, and there you go. It passes. It successfully events the transfer event like we expect. So now we want to actually reset the allowance. So whenever the transfer happens, we don't want you to be able to spend any more tokens for us. So we can, check the allowance. Basically just say, I'm just going to copy this example from before. Say it resets the allowance. All right, and then we'll say allowance token, allowance deployer exchange, allowance to string should equal, basically it should be 0. All right, and then we're going to set this inside of the smart contract like this. We'll do it here. We'll say allowance. We'll say from msg.sender equals allowance from msg.sender and sub value. All right, we want to reset the allowance after this is called. So let's run the test. All right, it passes. So now let's handle some failures. All right. All right, so here's the first failure we want to handle. Basically, we're going to try to transfer too many tokens. So this is a whole lot of tokens. It's like 100 million tokens. And that's way more, A, than the total supply, and B, way more than the exchange is actually approved for, okay? So we want to throw an error if the exchange tries to spend more tokens than we've allowed them to. So this will also handle cases where if the exchange tries to spend any tokens that we haven't approved, then, it's just going to fail. All right, the next thing we want to check for is that, it rejects invalid recipients. So basically, we try to transfer from the deployer to an invalid account. That's also going to throw an error. All right, while I'm here, I'm also going to rename this example. We'll say describe delegated token transfers. All right. So let's actually write the code to do this. I'm going to take out this space while I'm here, format our code. And, we've already got this taken care of because it exists inside this transfer function we wrote earlier. But let's make sure that we can, correctly guard against, the insufficient amounts. So we'll do that like this. Basically, whatever value is coming in, it needs to be less than the balance of the from account. All right, so the spender must have enough tokens to complete the transfer. And then also, the value must be less than the approved amount for the exchange itself. Okay, so this test handles both those cases. This is way more tokens than the spender has, or sorry, the from account has. And it's also way more tokens than they're approved for, okay? And you could go through and write all kinds of tests that check for other cases, but this will handle both, all right? So I'm gonna take out some of this dead space and let's run the test and see what happens. All right, so it looks like I got an issue with my JavaScript. I'm gonna go find out what happens, line 182. All right, so let's see what the issue is. We just forgot to close this out, so I'll do that again. All right, let's try it again on the tests. All right, it passes. We can see that it handles all the cases. So let's refactor a little bit. Looks like I accidentally added 2 failure cases here. So let's just not describe failure twice. Let's just describe it once. All right, pull that out. And then we'll run the test again. Refactor this a little bit. All right, and so all that works. We can see all these tests here, a nice nested fashion: deployment, sending tokens, approving tokens, handling delegated token transfers. We see all the success and failure cases. And that, ladies and gentlemen, is a complete ERC20 token per the ERC20 spec. We've just done everything required in this document, okay? And now we have a real currency that we can use on Ethereum and can be traded on the cryptocurrency exchange, which we're going to start building in the next video. So be very proud of yourself. Take a deep breath, take a breather. I know this bootcamp is moving at a fast pace, but you have just accomplished a major milestone, which is creating a full-blown cryptocurrency that can be run on Ethereum. So, yeah, congratulations. You've done a lot of hard work, and I'm excited to move on to the next video. We're going to start building out the smart contract for our cryptocurrency exchange.